Let's talk about addition rules for probability. If you are familiar with set theory, this should be a little bit familiar to you. Before we talk about formulas and definitions, let's look at an example. We have people divided out into married, never married, or divorced, and then separated into gender. The problem statement says, based on the data from the table, if a person is randomly selected from the representative population, find the probability that the person is divorced or male. So to find out if they're divorced or male, we can look at the table here and we can see that the column total for divorced is 24 and the row total for male is 115, and we can just add those numbers and get 139. However, this method is problematic. If I look at the row of males, so I have the 65, 40, and 10, that's what I add together to get that 115. Then I'm going to add the divorced people, so that's 10 plus 14 to get 24. Do you see what happened there? The 10 got counted twice. So we need to figure out a different way to handle this problem. Another way we can do it is just add up all the appropriate cells. So I'll say 65 plus 40 plus 10, and then I'll just add on that 14. And that will get me 129 out of my 228 people. Now this method works very well. However, we want to build something that is a formula. We need something that will work every time, even if we aren't given a table. What if I added the total number of males and then also added the total number of divorced people and then subtracted off that duplicate value? This is the basis for the addition rule for non-mutually exclusive events. The addition rule says the probability of A or B, and we're going to use the union symbol for or there, equals the probability of A plus the probability of B minus the probability of A intersection B. And that's what this little N symbol is. That means we're talking about the intersection. So now let's see if this formula will work. We want the probability of being male or divorced. So I need to do probability of male plus probability of divorced minus the probability of being male and divorced. Okay, so the probability of being male is 115 out of 228. The probability of being divorced is this column here, 24 out of 228. Then we'll subtract off the overlap. So I'll subtract off the intersection of being male and divorced, and that's going to be this value of 10 over 228. So now we have a formula that works, and that will get us 129 out of 228 that are male or divorced. Now, one little caveat is we are talking about non-mutually exclusive events. That means there is overlap. You can be both male and divorced. So let's do example 1. Find the probability when a card is drawn from a deck of 52 cards that it is a spade or a face card. Okay, a couple things. This problem statement has the word or in it. When we see the word or, we're going to start thinking about the addition rule. Also, it is possible to be both a spade and a face card. So that tells us we are dealing with non-mutually exclusive events. Now, I know what you're thinking. Let's just add up all those spades. There's 13. Then I'm going to add up the additional face cards. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll just do 13 plus 9. That's 22 out of 52, and we're done. Okay, that is one method. However, we are talking about the addition rule, so we probably should use that formula. So we want the probability of being a spade or a face card. This will equal the probability of being a spade plus the probability of being a face card minus the probability of being a spade and a face card. The probability of being a spade is 13 out of 52 because there's 13 spades out of our deck of 52 cards. The probability of being a face card, well, there is 3 face cards for every suit times 4 suits. So that's 12 out of 52. The probability of being a face card and a spade will be 3 out of 52. So now I have all the pieces, I can just write out the whole thing. So 13 50-seconds plus 12 50-seconds minus the intersection of 3 50-seconds. Now just a quick reminder, when we're dealing with addition and subtraction of fractions, the denominator must be the same, which, hey, we're in luck. It's already 52 for all of these. So I'll write 52, and then we can just add the first two. So 13 plus 12, that's 25, minus 3, that's 22 for the numerator.